Hi, my name is Lanston Chu, a graduate student from University of Wisconsin-Madison, and my talk is called Machine Learning on Gun Protest Diffusion, Cluster-Tree-MLE Analysis in Space-Time Metric Space. Hi everyone, my name is Lanston Chu, a graduate student of the University of Wisconsin-Madison. I'm so happy to present here. And my talk is called Machine Learning on Gun Protest Diffusion, Cluster-Tree-MLE Analysis in Space-Time Metric Space. Protests for stricter gun control have gained momentum since Donald Trump took office in 2017. The mass shooting case in Marjory Stoneman's Douglas High School in February 2018 and the national walkout set another wave of gun control protests across the country. These Trump-era protests have led me to raise a question that have huge social impact. How have these gun control protests spread within the United States? The existing mathematical model for diffusion and for social movements mostly focuses on either time or space dimension, but they seldom combine the two. The temporal mathematical model focuses on time versus the number of participants. It can be time series or differential equations of growth, but the geographical variation are limited. And for the spatial one, it evaluates outbreaks statistically, and the analytical ability of the theories are also limited. And this project does just that. I try to combine this time and space dimension and form a combined space-time metric space. Before I move on, okay, I slowed this one down. Before I move on, I would like to explain the main object of this project. So what is diffusion, and why do we concern about diffusion? Sociologically speaking, diffusion refers to the spread of something within a social system. For the case of social protests, there are enlightenment and encouragement effects to the subsequent effects. So that means if you join a protest, or if your friend joins a protest, it's likely that you would want to join too. And so the geographical factor plays a key role in the spread of the movements. And in the Jasmine Revolution in 2012 that swept across the Middle East, we can see that the geographical factor really matters. So now it is the visualization of the data. There are more than 2,600 gun-related protests from March 2017 to June 2018. And this is the time crystal that I've mentioned, combining the space and the time dimension. You can see the x-axis are the spatial dimension, that is the longitude, latitude, and the z-axis are the time dimension. You can see each dot represents one protest event, and the number of protests just skyrocketed since spring 2018. After the mass shooting case in Parkland, there are three big waves of the gun-related protests, namely the school walkout, the March for Our Lives, and the 19th anniversary of the Columbine High School massacre. And you can see inside this time crystal, there's a vessel shape of United States, and all of this transposed to a map of United States just at the bottom. And there's a cloud of dust as the constituent of the time crystal, and it looks like a Lapulla map of astrophysics. So you may ask, there are lots of dust. So which dust will lead to which one? And what are the relationship between the dust and how they can be grouped into different clusters? To answer this question, I would apply a technique called cluster analysis, which is a machine learning technique, especially in the unsupervised learning. And this technique is mostly for the task of grouping. And here we are. We have this 3D plot. You can see that the Lapula map, the dust of cloud, allows separate into 9 different clusters. And by using the combined metric space of space-time metric space, we can now have a well-defined Euclidean distance. So each dot, they have a distance between, and I can measure some of the dots may have a shorter distance between the two, and some of them may have a longer distance. And this cluster analysis technique would group the neighboring dust into the same cluster. So now we have a line cluster. And before moving on, I would like to look at a technical point, that is, what is the ratio between time and space? That is, how many days in time is equivalent to how many kilometers in space? In fact, this ratio leads to make sense sociologically, so to speak. And our hypothesis is that when one protest occurs in one locality, some people may encourage their friends or families or comrades to join a protest or start a protest somewhere else. So we will measure the necessary distance of travels of people making necessary trip from one county to another county inside the country. And the space-time ratio would take consideration of this. So you can see we can also group the cluster in ellipsoid and also in the convex holes. And now we may ask, what do all this mean? What is the relationship between this cluster to, let's say, the Maastricht case? We want to see the relationship between the two, and we will mostly focus on the severe Maastricht cases. There's a threshold value theory in statistical modeling and in sociology. That is, some threshold value is very important, and the system may have different behavior before and after the threshold value. For the case of the protest, or for the case of the Maastricht case, if there are more than certain people being wounded or killed, it may disproportionately draw more attention from the public. And for this study, the threshold value that I set is 5 or more people being killed and 9 or more people being wounded. You can see the red spots and yellow spots represent the threshold value that I've mentioned, and the black spots is the cases that fulfill both the conditions. This one is the Parkland case, and you can see different severe cases inside the time crystal. So now I can combine the clusters and the Maastricht case. You can see there are significant relationship between the two. The Maastricht case touch the bottom of the clusters. It's just like the spots are supporting some floating megastones. Let's say the notorious Parkland shooting case touch the bottom of the clusters of the 3 races, the School Walker March for Our Lives clusters. And for this big one, there are some red spots and also, okay, let me slide that. And also some yellow and this one yellow and red spots touching the bottom of the cluster. So that means it's some kind of the Maastricht case initiate the cluster. But there's also a question. Inside each cluster, how do one protest lead to another? That is, how the protest diffuse. And it is the gist of the project. I use a technique called spanning tree, which is in graph theory, there's a tree that includes all the vertices of the graph with minimum possible number of edges. I make the spanning tree for different clusters. So we have line cluster, we have line trees, and it is the fourth tree, and it is the fifth one, and it is the biggest cluster. Inside each cluster, I construct a spanning tree from the leveraging of the protest. That means the edge of the tree means the jump between the protest. That is, from one protest lead to another one. So we now have the tree, and we want to know how to model this jump or model the edge of the spanning tree statistically. So we will use a technique in probability, in statistics called maximum likelihood estimation, MLE in short. We can see that the jump of the protest basically follow an exponential distribution. The left one is the probability plot comparing to a normal distribution, and the right one is the probability density function of the jump. That's the PDF. So you can see the curve of the exponential distribution fit the statistic quite well. By using MLE, we can find out the parameters lambda of the exponential distribution model. So, yep.
Did you run fine distribution to see if there might be other distributions than exponential distribution to fit the data better?
This one I mostly use exponential distribution, and I tried to use another one, but didn't quite the PDF well. So I did it. You can say qualitatively, but by MLE mostly we choose the model first, and then we determine the parameters. For this one, I think also makes sense to use exponential distribution as the in the diffusion we assume that the geographical factor matter. So that means the neighboring county or the neighboring location is much more probable to be infected by the neighboring location. So that's why I picked exponential distribution. And yep, it is why I choose this one. Yep.
It's the same distribution that's used in modeling molecular interactions of life dynamics.
Sorry?
It's the same type of distribution that's used in modeling chemical kinetics.
Yeah.
Stochastic processes. So it makes a lot of sense that you're following a diffusion type process.
Yep. So for this one, mostly I want to find a simple modeling for the jump process so that we can have we can further analyze the jump by using the model. Yeah. So that's why I picked this one. Yeah.
Is there like sociological literature or reasoning that this model ought to fit?
In fact, the previous study didn't combine the space and time very frequently. Most of the time they look at the process separately. So for this one, I combine it and I try to see how the jump really looks like. Yeah, so I just pick something that is reasonable and simple, and exponential distribution is the one that I picked. Probably there may be some other more complicated distribution that fits this one, fits the statistic more, but exponential distribution is a reasonable choice. Yeah. Then I want to show how the diffusion really looks like on a United States map. It is one of the cluster before the 3 big waves of the protest. That is a cluster from October 2017 to March 2nd, 2018 in the west coast of the United States. You can see that the protest originates from Southern California and then it spread out. We can observe that the neighboring counties are more likely to be infected by the counties that already have protests. And then it takes some time to spread out the protests, which is a different pattern to the burst that I'm now going to explain. Okay. This is another cluster, which is located inside the time of waves, that is the 3 big waves of protests from March 3rd to March 31, 2018, also in western United States. You can see there are bursts of protests. At one moment, just all of the protests explode, and all of them just appear in a single moment. So you can see that the geographical factors are much less significant, and all of them just happen in a very short time frame. That means the previous one, the geographical diffusion, adds on a longer time frame, and this one adds on a relatively shorter time frame. To sum up, there are 2 main drivers in the diffusion, namely the geographical diffusion and the burst. The spreading pattern of them are different. The first one is more geographical, and the second one have less geographical bound. And thanks to the internet, we can expect that the pattern of the burst would happen much more frequently than the past. And we can also use different kind of tool to analyze these 2 types of pattern. For the geographical diffusion, we can use the technique of this project, that is the Cluster-Tree-MLE analysis for geographical diffusion. And for the burst, I would suggest some more traditional technique, say time series for the burst. It is also expected that the technique of Cluster-Tree-MLE analysis can be applicable to other areas regarding infection and other areas of diffusion, say the contagious disease or other social practices. I would like to summarize my presentation by using a quotation from Albert Einstein, who says, "Time and space are not conditions in which we live, but most by which we think." I hope my presentation have provided some novel ways of data visualization and data analysis for social problems, and it can make us to rethink time and space sociologically. And that's the end of my presentation. Thank you, and I'm happy to take any questions.